Alrighty, 3.2b. Okay, this is where we're going to start dealing with story problems with our systems of equations. There's some practice there. Those are in your OneNote, so if you need some practice with substitution or linear combinations or elimination, as I refer to it as, go ahead and do those problems. But for this lesson, let's go ahead and worry about the story problems. We're going to see three different types. Those are the three right there, two totals. Distance is equal to rate times time, and then some math language as well. For the first one, okay, for each of the following, designate two variables and set up a system of two equations to model the problem. Okay, designate two variables. That is the first thing we do with any word problem. We need to designate those variables, okay, define them. So, for the first example, 8 pens and pencils cost $3.37. A pen also costs 1 penny less than twice a pencil. How much does each pen and each pencil cost? So when we're doing these, what we need to do is let's go ahead and let's just highlight the important information. We got 8 pens, 7 pencils, and that costs $3.37. Okay, that's where we're going to get one of our equations. The next equation we're going to get from the next sentence. A pen also costs 1 penny less than twice a pencil. Okay. And then the last thing that's important is how much does each pen and each pencil cost? Okay. Now, when we're looking at these, the actual question is what's going to help us define the variable. The actual question is here is how much does each pen and each pencil cost? Okay, so that's what the variables will be. Now, typically I like to use the first letter of each variable. Okay, like in this case is pen and pencil. Since it's P and P, I'm going to go ahead and use X and Y. Now, the thing I don't like about this is that you need to make sure you're keeping track of which X is and what Y is, okay? So for X, let's say cost of pen, Y, cost of pencil. Okay, so then we're looking at the green there. Okay, 8 pens, 7 pencils, cost $3.37. So combined, they're $3.37. So that's a total. Okay, and we're combining two things, so that's two totals. Okay, now to figure out how much the pens cost, it's going to be 8 times the cost of the pen. Just like if you were to get one pen, let's say it's 50 cents, one pen is 50 cents. 2 pens is $1, 3 pens is $1.50. Okay, it's however many pens you have times the cost. So 8, we have 8 pens times the cost, which we represent with X. Okay, but then we have to add the pencils as well. So we have 7 pencils times the cost of the pencils. So there's our first equation. Now let's go ahead and write the second equation. A pen also costs, so a pen, which is represent X, costs 1 penny less than twice a pencil. So twice a pencil, 2Y, and then 1 penny less. Okay. Now, common mistake will be minus 1. Remember, 1 is $1. Okay, 0.01 is 1 cent. Okay, so now we have our system of equations. Now we need to use one of those methods we have learned to solve for this system. Now I see that X equals equation, our purple equation there. Okay, that has isolated a variable already, so I'm going to go with substitution in this case. So I'm going to plug this in for X into the top equation. So 8 times 2Y minus 0.01 plus 7Y equals 337. Okay, now we have just one variable. So I'm going to go ahead and solve for Y here. So we got 16Y minus 0.08 plus 7Y equals 337. Combining my Y's there, I get 23Y. Adding that 0.08 to both sides, I get 345. Okay, divide by 23. Divide by 23. Plug that in to your calculator. You get Y equals 15 cents. Okay, so now we have solved for the cost of pencils. So now we need to go ahead and find x. Okay, I'm going to use that nice equation where it's x equals already. So plugging y in for there, you get x is equal to 2 times 0.15, just replacing that 0.15 into the equation, minus 0.01. So x equals 30 cents minus 1 cent, or a pen will cost 29 cents. Now, anytime we have a word problem, the way we answer word problems is with a sentence. So, each pen will cost 29 cents, and each pencil costs 15 cents. Okay. So there's our example of two totals. Okay, next problem, we have a distance equals rate times time. Now, anytime we do these, let's set up a table. Okay. We got distance equals rate times time. Okay, and since it's two variables, we're going to have a 3 by 2 by 3, sorry. Okay, but now when we setting this up, okay, again, we need to define our variables. So let's go through, let's read and highlight the important information. Anne can paddle her canoe 50 miles downstream in 2 hours. Okay, the return trip, which would be the upstream, takes 3 times as long. Okay, now the return trip, that is going to be the same exact distance. So we got our distance there. What is the rate of the current? What is the rate of Anne's in still water? Okay, rate of the current, Anne's rate in still water. Again, the questions will tell you what the variables are. Now, this is where I would say I would use C for rate of the current. And then A for Anne's rate in still water. Okay, so the way we're going to break this up now is we have two different trips. We have upstream and we have downstream. Okay, now the distance was the same for both trips, so 15 and 15. And then we also are given the times. Okay, Anne can paddle her canoe 15 miles downstream, so we're talking about downstream in 2 hours. Okay, on the return trip upstream, it's 3 times as long, so 3 times is 2 hours. We get 6 hours. Now, when we're talking about rate, this is where it's kind of tricky. Okay, if any of you have ever gone canoeing or kayaking or anything, when you are going upstream, okay, that's meaning you're working against the current. Okay, so when you're doing this, you have your speed, or in this case, Anne's speed, and then you have that current working against you, meaning it's going to slow you down. So we need to subtract the rate of that current. Okay, and then just the opposite when we're going downstream. Okay, you have your speed, or in this case, Anne's speed, and then that current is speeding you up. Okay, so then our two equations in this case, 15 is equal to A minus C times 6, and then 15 is equal to A plus C times 2. Now, what I'm going to do to make this easier is I'm going to divide that top equation by 6, both sides, the bottom equation by 2. So the equations that we're going to deal with now are A minus C equals 15 6, and then A plus C equals 15 halves. Okay. Now, so imagine this is our system here. Okay, the method I'm going to use at this point is elimination. Okay, I see that this variable C there are opposites, so when we add those up, the C's go away, and we're left with 2A equals 15/6 plus 15 halves. Okay, so 15/6 plus 15 halves. Okay, we need a common denominator. So in order to find that equivalent fraction for 15 halves, I'd multiply both top and bottom by 3. So 15 times 3 is 45. 2 times 3 is at 6. Now we have those common denominators. So 66 or 10. Okay. So now we got 2a equals 10. Divide by 2. We get a is equal to 5. Okay. So Ann's rate in still water is 5 miles per hour, since we're in terms of miles and hours. Now we need to go ahead and we need to find the rate of the current. So again, pick one of the variables, or one of the equations, sorry. So I'm going to go back up to one of these original ones. And let's use the bottom one, just since it's got a plus c times 2. So ignore the division by 2. We got 15 is equal to, we got Ann's rate, which is 5, plus c times 2. 15 is equal to 10 plus 2c. Subtracting that 10 over, we get 5 equals 2c. Divide by 2, 5 halves, which is also 2.5. Okay, so again, finishing off these problems, we need to write a sentence, and we're answering what is the rate of the current. The rate of the current is 2.5 miles per hour, and Ann's rate in still water is 5 miles per hour. Okay, so there we have our distance equals rate times time problem. Those are typically the harder ones. So big thing there, set up the table and remember that it's rate times time, so that's a minus c in parentheses, that quantity times the time. All right, last one. A grocer mixed nuts worth $4 per kilogram. That's probably pretty important. With raisins worth $3.25 per kilogram to make 15 kilograms. A mixture worth $3.60 per kilogram. How many kilograms of nuts and how many kilograms of raisins are in the mixture? Okay. So again, defining our variables. Nuts, raisins. So kilograms of nuts, kilograms of raisins. Okay. So a grocer mixed nuts worth $4 per kilogram with raisins worth $3.25 per kilogram to make 15 kilograms of a mixture. Okay. So what we need to do is we have a total of 15 kilogram mixture. Okay. And it's comprised of the nuts and the raisins. So the kilograms of nuts plus the kilograms of raisins equals that total mixture, which is 15 in this case. Now, for the next equation, the nuts are worth $4 per kilogram, raisins worth $3.25 per kilogram, and we have a 15 kilogram mixture worth $3.60 per kilogram. So this is kind of a tricky one because it doesn't actually give us that total. Okay, but we do know, okay, $4 per kilogram for the nuts plus the $3.25 per kilogram for the raisins. Now we don't know the total, okay, because remember this 4N is representing the price for the nuts. This $3.25 is representing the price for the raisins in this mixture. But then the total price for the mixture, okay, we know we have 15 kilograms, but it's $3.60 per kilogram. So we have to take that times 15 to give us that total cost for the mixture. Okay. So let's go over here. Nothing's going to change with that first equation, but let's just simplify that second equation, because 360 times 15 will give us 54. Okay. Then from there, we need to determine a method to solve that system now. What I'm going to do is I'm going to use elimination, multiply this by 4. So then we get, I'll use blue for the next step, 4n plus 4r equals 60. Nothing to do with the second equation. Oh, I missed an r there. Okay. So then eliminating our n's, subtract 4 minus 3.25, 0.75, 60 minus 54, we get 6. Okay, so and then dividing by that 0.75, divide by 0.75, these are r's, r is equal to, let's see, 158. Okay, so then we have 8 kilograms of raisins in this mixture, and we have a total of 15 kilograms for the mixture. So 8 plus what is 15? So kilograms of nuts will be 7, because 7 plus 8 is 15. Then finally, finishing off the question, actually, how many kilograms of nuts and how many kilograms of raisins are in the mixture? There are 8 kilograms of raisins and 7 kilograms of nuts in the mixture. Alrighty. So that's another 2 totals there. Those are kind of tough. Just make sure you need to set up your equations. That's the biggest thing with any of these problems, making sure you set up that system of equations, and then from there it's a matter of solving using one of those methods that we have learned. Okay, later on we'll learn a little easier method of solving in my mind, and you are allowed to use that later on. As of right now, we need to use either combinations or substitution. Okay, so your homework for this lesson will be the word problems. Story problems practice. Okay, there is another one here. That's just some extra practice. So either one, make sure you work on those. Other than that, have a good day.